Okay, I'm Terry Camersell, and I'm here on behalf of Creation Fellowship Santee. We're a group of friends bound by our common agreement that the creation account, as told in Genesis, is a true depiction of how God created the world and all life in just 6 days, a matter of about 6,000 years ago. We've been meeting in this online format since May of 2020, and we've been blessed by a wide range of speakers, some pastors, authors, scientists, doctors, all sorts of people who love the Lord and have a message to share. And you can find links to most of our past presentations by typing in tinyurl.com/CFS archives. That's C like creation, F like fellowship, S like Santee, and the word archives. And while you're there, you can also click on the list of our upcoming speakers. We still have a couple more remaining for 2023, and soon we'll be adding our list of 2024 speakers, so you'll want to check those out. You can also email us at creationfellowshipsantee@gmail.com. We promise not to spam you, but we'll send you links to all of our upcoming speakers. Tonight, we're super blessed to have back with us Nate Loper. Nate is the executive director of Canyon Ministries, which provides creation-based rim, backpacking, and rafting tours of the Grand Canyon. In his previous role as a pastor, Nate traveled the nation teaching in churches, schools, and Christian universities for over 20 years. He has also led tours through dozens of national parks and natural history museums in both the United States and the United Kingdom. Earlier this year, Robin and I got to take a road trip up the West Coast of the United States, and we observed a lot of beautiful shores and rock formations, and we were curious about how they got there. So we invited Nate to come and talk to us about coastal geology. With that, Nate, I'm happy to turn it over to you.
All right. Well, thank you, Terry. You kind of gave me a big topic here, coastal geology, because there's a lot of coast in America, and there's a lot of rocks out there too, a lot of that geology. So there's a few things we'll talk about tonight, but let me go ahead and start this sharing here, and hopefully that will come up correctly. There we go. I think that should be up. So yeah, tonight we're going to talk about coastal geology, and I used to live myself down there in Southern California, right near the coast. So quite familiar with California coastlines and the geology. And of course, I've also been fortunate to take some of those road trips up the coastline. And so I've been through California and Oregon and Washington and seen just there's such a vast array of beauty and of God's creation on display. There's also a lot of variety as well. And so, when it comes to coastal geology, and when we do have a lot of coast we could talk about across the entire world, and there are some beautiful coasts that stretch all the way across the world and throughout many places, we can see anywhere. But tonight we're really going to focus primarily on the kind of the coastal geology that you have right there in California. And that's kind of the West Coast, California, Oregon, Washington, the kind of Pacific Coast geology. And so tonight, my hope is to maybe do some overview of some of the things that you might see on the coastline or nearby the coastline even. And then how do some of these, coasts get formed? How do we see this from a biblical, creation and flood perspective? And then, what do we see and how does it, speak to things like the global flood and evidence for that? So we'll cover a few things like that. So I know I do sometimes talk kind of quickly, and there's a lot of topics we may kind of cover tonight. Now, any one of these topics could be a whole entire discussion just by itself if we wanted to, but we'll kind of touch a few different things. And the nice thing about, even if I do talk quickly, the nice thing is it's a video, so you can stop it, pause it, rewind, and catch up a few things. But anyhow, the California coast, especially that coastline, the Pacific coast, really is, in some people's opinions, some of the most beautiful landscape to drive through. We've got that Pacific Coast Highway, California Highway 1 that goes basically all along that coast, and you can take that and just see stunning landscapes and different features and formations from a kind of almost desert-like sands down in Southern California to, rocky coast and cliffs and, beautiful trees and forests and all kinds of things that you might be able to see. So there really is a variety along that coastline that you would see as you're traveling up or down the Pacific coast. And so It's one of my favorite things to do. I used to live, like I said, in Southern California. I lived about 8 years there in Los Angeles area. So naturally, one of my favorite things to do when I lived in Los Angeles was to drive out of Los Angeles and go see other things in the state, because it wasn't my favorite place of the state, as you can imagine. But driving along, whether north or south, going down to like San Diego, beautiful landscape up there, taking trips up to San Francisco and beyond. There's just so much to see, and I love driving, and that's a good thing because with Canyon Ministries here, our offices are in Flagstaff, but the Grand Canyon is an hour and a half away. So every time we're doing a tour, we're driving a 3-hour round trip every day that we're going up to do tours. So I don't mind driving. I kind of like it. Lets you see the landscape and lets you have a lot of time to just kind of go through your thoughts and prayer and listen to a lot of books on tape. But anyhow, looking at the California coastline, you do have a vast variety of different landscapes, and not just in geology, but there's a lot of different things regarding plants and animals and just all sorts of different things to see. And so again, tonight we're not going to be able to cover every detail of it, but we'll cover a few different things. And beyond just speaking about the actual like coastline of where the water meets the sand or the rocks, I kind of consider like coastal geology to kind of be not just right on the coast, but even things maybe a little ways inland from the coast. There are fantastic mountain formations and things like that we see that are kind of considered kind of that coastland environment, things that really almost these mountains that play into why we have the coast and why you have the type of environment and ecosystems that you might see on the Pacific coast. So I would kind of consider coastal geology to be kind of from the ocean to maybe 50, 60, maybe up to 100 miles inland, but basically some of the areas have to do with that coastland environment. And so there's just tons of stuff to see. And so one of the big things, of course, you see as you're driving, for example, from where I live here in Arizona, if you're driving to the coast, you do go through some pretty good mountains. And as you're driving up the coast, you can see some spectacular mountains. And I've been into Seattle a number of times and just seen some really awesome, spectacular mountains from between there and down to Portland area. And, I grew up in Colorado and used to seeing mountains and pretty familiar with mountains. But tell you what, the first time I flew into Seattle, we were flying by one of those big, massive mountains just right out the airplane. I was just amazed because this thing is just massive prominence rising up and just right there next to the water. And it was just so stunning. So coastal geology, I think, has a lot to do with not just the sand and the rocks by the water, but also kind of what's a little bit inland. And again, what some of that to help shape the geology you might find in the coast. So speaking of these mountains, how do we see mountains form? That's one of the big questions that people oftentimes ask. Where do those big mountain ranges come from? Like when you see, the Cascades, or you go down and you see mountains further south from there, where do these mountains kind of come from? And so from our perspective, when it comes to a creation and flood, geology perspective, we see a lot of those mountains and mountains throughout the world really as a result of the flood in Noah's day, by and large. A lot of our major mountains that we see and are familiar with today, we believe were the product, a result of these year-long flood processes or shortly thereafter. So something to think about when it comes to mountains, things like the Himalayas, the Rockies, the Andes, the Alps, the Appalachians, the Sierra Nevadas, the Cascades, a lot of these mountains that we see and are familiar with today, we believe were formed during the flood, and most of those probably pushed up and through flood waters. And it kind of helps us to understand when you study the geology around the coast and you see these mountainous formations along, basically along coastal regions, you get an understanding that during the flood, it's not simply just a mere water event. This is not simply waters covering the earth, but during this year-long flood process, we would have volcanoes erupting around the planet. Again, we'd have earthquakes going off, we'd have tectonic forces, we'd have a lot of stuff taking place. And during the flood, we believe that the plates, many of our tectonic plates around the world, were broken up. And that during the flood, there's pretty good evidence in geology that during this flood, that they were moving around, they were jostling, they were shifting around. And in some cases, they were colliding together. And as they collided, they came together, in some cases buckled and forced up huge major mountain ranges like the Himalayas, where you typically see two continental plates coming together as India comes slamming into Southeast Asia and they collide and push up. And in other cases, you have other plates doing different things. Well, when we look out into the Pacific Ocean and we start to examine the plates that we have out there, we kind of see, and geologists have kind of put together their ideas of kind of 3 to 4 major plates that you would see out there in the Pacific. And so this map you kind of see here, this is kind of a little loose illustration of maybe what these plates would have looked like before the continents kind of are the shape they are now. Interestingly, when it comes to science and geology, truthfully, we kind of do agree by and large with a lot of mainstream geology, with the caveat, with the difference being mostly how quickly we would see things formed and maybe how recently we would say that they were formed. So we do believe in things like plate tectonics. We do believe in things like the continents moving. But instead of, continental drift over millions of years, a slow, gradual movement like we see today, we would be talking more like continental sprint, right? So rapid movement, rapid changes. And so big process happening quickly because this year-long flood is such an impactful event that's taking place. So again, kind of continental sprint. And as these continents are coming together, again, they're colliding in train wreck-like collisions. They're buckling and forcing up these huge major mountain ranges. Today's present processes that we see of geology, slow, gradual uplift and movement and separation, today's present processes, I don't believe, can explain necessarily what we would see happen in the past. Because the past holds some pretty key big events and some really big things that we don't typically see happening today. Of course, you and I weren't there since the beginning in the past. So what every geologist, what every scientist has to do when it comes to understanding the past is they have to, either make inferences based upon what they observe in the present, or they have to rely upon another, source of authority or information. Now, fortunately, we are given God's word, the Bible, as a key eyewitness, if you will, a history book of the universe. We're given that as a source book to be able to understand some of those events of the past. And so when you understand, again, what the Bible is really talking about, you realize that the flood that it describes in Genesis 6, 7, and 8 regarding Noah's Ark and Noah's flood, you come to the understanding and realization that this flood is the largest major geological change that the world has seen before or since, most likely. This is a huge, huge event taking place. And so what we see are changes and shifts in tectonic plates, but again, not the slow, gradual uplift of millions of years, more of a rapid and catastrophic. And that at the end of the flood, all that kind of comes screeching to a halt for the most part. But we do still see some residual movement. We still see some residual uplifts. And, we still see these plates kind of moving together. So by and large, and I've been to plenty of presentations. I've been to some fantastic presentations from everyday secular geologists who don't agree with our perspective of creation or the flood or how recently things would have happened. But I've been able to go to these presentations and actually learn quite a bit from that perspective. And really, truthfully, by and large, I look at it and say, you know what? I agree with a lot of what you're saying, except for the time and the speed and the mechanism. So there's a lot in the standard geological processes we actually do agree with. So one of those things are plates. So in this illustration, this model, you can see some 3 major plates that you would see that would be out there into the Pacific Ocean. Now, one of the major ones we want to talk about and focus on right here is this kind of Farallon plate that we see there. And so this would have been a major plate that we believe was in the Pacific Ocean. And we do believe that plates, again, they move. They sometimes push together. If they are continental plates, then they're going to push together and they're going to have a hard time, jostling one another. But sometimes in the oceans, we have oceanic, tectonic plates. And what you would see is in the ocean that the ocean floor plates are typically more dense and they are heavier material because they're made up of basalt. And so kind of the average density of basalt is about 3 grams per cubic centimeter, I believe it is. And so what you have there is a heavier, kind of denser material, whereas on the continents, the average weight's about a granite, which is about 2.7. And so what happens is when you have heavy, denser, like basaltic plate material from the ocean bottom, when it comes in contact with the more light, buoyant, crustal or coastal areas and where the continents are at, what's going to happen is the lighter material is going to float on top of it, and the heavier, denser material is going to kind of go down and subduct and go down into the asthenosphere, and then pushing its way down where it starts to get in contact with the heat from the mantle and begins to liquefy. And that can do a whole lot of interesting things. So when you look here at this Farallon plate, this kind of shows us probably, what things would have looked like before the flood stages. We don't know exactly what the arrangement of the continents were, but probably definitely different than we see today. During the beginning of the flood, we believe, and during this year-long flood process, some of these plates were actually subducting, and they were going underneath one another. So, for example, the Iznagi plate would be subducting and kind of going underneath where you see Japan. That Farallon plate would have been subducting underneath what we call the North American plate. And today, pretty much most of that Farallon plate is completely gone. There are some trace members of it kind of that we would see here and there, like little pieces of the Juan de Fuca. That's a small section of it. We have the Cocos plate. I think it's Cocos plate down to the south, and the trying to remember the other name of the plate down there, Nazca plate, that's down there by South America. So those are kind of members of that whole plate. But by and large, the Farallon plate is pushing and it's coming in contact with the North American plate. So what happens is, to make these mountains, we have kind of this mountain building phase taking place right along the coastal areas. And I'm sure a lot of you guys have noticed, but if you look at major coastlines, especially like going down the entire west coast of the United States, all the way down through the western coast of South America, you see some pretty big mountains. We've got, the big major mountain ranges going down all the way down to South America there, where you have the Andes kind of pushed up. And so what's happening are these plates are coming in, they are subducting. And so you can see here heavier, more dense ocean crust material, because it weighs more, because it's mainly basalt. It's actually coming in contact and it's heavier, so it sinks down underneath the lighter kind of granitic continental plate material. And so what's happening there is it's subducting, it's being pushed down. And it's almost like a giant conveyor belt, if you will. You've got material from the ocean floor that's kind of moving, and maybe there could have been pre-flood islands out there that we have no trace of anymore. There could have been whatever was on the oceans at that time. But there's kind of like this giant conveyor belt that's coming against and contacting and pushing against the continental crust. And as that oceanic crust is pushing against there, it's even sometimes bringing in some material that many geologists call kind of the accretionary stages, or accretionary of continents. And basically imagine like you've got a conveyor belt moving. And if you remember the old I Love Lucy TV show, and when they were there, I think it was at the chocolate factory, and they have all this, coming by, and they kept checking, and they kept pulling all these chocolates off of there and trying to figure out what to do. And she's eating them. It's like nonstop. All these, chocolates are going down the conveyor belt. Well, imagine we had islands out there in the ocean, or other, subterranean, underneath the water, landforms that are being carried on that conveyor belt, and they're kind of colliding with the west coast of the United States during this year-long flood. And it's pushing material, it's kind of accreting them onto the coastline areas. And so we actually have some stuff pushed together. This subduction creates what we call the accretionary wedge. And so it's kind of a push of all this material kind of crumpling together on the surface. It's kind of the lighter stuff is kind of scraping and getting pushed on, whereas the heavier, denser basaltic ocean crust is subducting down. And so what's happening, though, is as that basalt heavy material goes down into the asthenosphere and starts to get liquefied down there, you start to kind of warm it up because of the heat of the mantle, but also just the friction of these coming together. That friction starts to create a melt zone. That material starts to de-water. It starts to lose the water it has with it. It starts to boil up as steam. And so we have this kind of liquefied rock zone. And then you also have a lot of water contained within it. And eventually that heat and that pressure can start to force its way up through the continental crust and form many, many volcanoes. And so that's kind of what we see with a lot of these major mountain ranges. A lot of these ranges have some big volcanic activity associated with them, or places where mountains have been kind of crushed up and crumpled up. And even sometimes heat and pressure from this process is changing rock material, turning into kind of this metamorphic rock stage. So the rock is undergoing this metamorphic change. And so if you remember from school in geology, all rocks around the world fall into one of three different classifications, right? So we have sedimentary rock, Typically think of rocks like sediments like glued together sand grains, things like sandstone and limestone and shale. So we have sedimentary rocks, and then we have igneous rocks. And those igneous rocks are rocks that have come up from these lavas and volcanoes and things like that. Igneous rock, like the word ignite, it's a great way to think of it. So we have igneous rocks, and then we have a third rock type called metamorphic rock. And so metamorphic rocks are rocks that have undergone a change by heat and pressure. So heat and pressure kind of squeeze it, melt it, typically realigning the crystalline structure, making a much stronger rock in the end. And that usually is, again, the product of heat and pressure. Well, when you have these plates coming together, there's a lot of heat, there's a lot of pressure, and so it can actually change and transform those rocks. And so metamorphic rocks. And so similar to a word we have often used like metamorphosis, right? Which of course is the process of a caterpillar becoming a butterfly. And so from the Greek, to metamorphose, to change in its nature or in its form, which is a pretty neat word because the Bible actually uses that word to kind of describe us, how we are changed and transformed into the image of Jesus Christ. So we are ourselves metamorphic in nature, you might say. We've been changed and transformed. So anyhow, when you're looking at coastal geology, we have all three of those major rock types represented that you see all over. We have the sedimentary rocks, we have the igneous rocks, and we have those metamorphic rocks. And we believe a lot of that took place either during the beginning of creation. So when, day 3 of creation, when God drew the water to one place so that dry land would appear, we'd have a lot of movement, we'd have a lot of uplift, a lot of changing and all kinds of stuff. We'd also have a lot of erosion off the continents as the water's draining off. So we'd have a lot of sedimentary rocks formed then. And then during the flood, we would again have tremendous changes happening for this year-long flood process. So we see a lot of that happening during this year-long flood, we believe. So during this time, we have major big volcanoes that are being thrust up. And so again, liquefied rock from either melting heat, down below, but especially from friction from these plates coming together. And so rising up. And so not only lava and magma are coming out of volcanoes, but we have a lot of steam. In fact, one of the biggest things coming out of volcanoes is not lava, but it's actually steam. And these big steam explosions that make these big, phreomagmatic explosions of volcanoes. And so we see a lot of water vapor coming out of volcanic vents. And so, again, a lot of that's associated with some of this water being pulled down through this whole process of plates subducting, as well as groundwater penetration down into those zones. So you look at coastal geology, and we do see a lot of mountains made up of igneous and especially metamorphic rock, and we see a lot of volcanoes. And it's actually the very thing that Scripture talks about as well regarding the flood. Again, the flood was not just about a mere water event. This isn't simply water covering the earth, filling it up like a bathtub, and then you pull the plug and let it drain away and the water all disappears. No, the Bible, again, describes the flood as a major, huge, catastrophic event, and it's really a tectonic event too. During the flood, again, mountains, volcanoes, all kinds of stuff being formed. And again, Scripture gives us that indication as well too. Psalm 104 talks about the flood. And Psalm 104 verse 8 tells us that during this flood that mountains rose and valleys sank to the levels that God decreed. So what we're looking at is during this year-long flood, we would have major mountains that are rising up. And so especially near the end of the flood, as the flood waters are receding off the continents, we would have mountains that are being thrust up, that are rising up from below. And so we have valley floors that are being ripped open. We have a deepening of the ocean basins, we believe. And we have mountains that are rising, in some cases, to incredible heights across the continents. Again, most of our major mountains, like the Himalayas, the Rockies, the Andes, the Alps, the Appalachians, the Cascades, the Sierra Nevadas, all those things we believe were formed either during the flood or shortly after that. And again, most of that, again, triggered by the flood. And it also helps us to understand that when it comes to these mountains that we see, especially in these coastal regions, we don't necessarily need maybe as much water to flood the earth as what some people might think. People look at things like the Himalayas and you say, oh, the Himalayas are risen to incredible heights and, 29,000 feet in elevation, right? You're telling me that floodwaters rose to 29,000 feet? And I say, no. Well, and they say, oh, well, then you either don't believe your Bible or the Bible's not true because it said all the mountains were covered by water. And I say, yes, it does. And then they look really confused. Now, those mountains, I would say, were not formed before the flood, so therefore they were not covered to 29,000 feet by the flood waters. They were formed during the flood. And so the pre-flood world probably did not have nearly as high mountains as what we see today, nor as deep an ocean basin even. I think both were greatly increased during this year-long flood. Again, mountains rose and valleys sank to the levels that you decreed. That's what it talks about the processes. And we believe that happened during the end of this flood, especially. And so, again, we look at the coastal region, especially there on the West Coast, and you do see some pretty impressive ranges of mountains. We have the Cascade Range, which you typically see not too far from the coast, like you can see there. So, the Cascade Range, which goes, all the way down from Washington through Oregon and into parts of Northern California. And so this mountain range, we believe, was part of this orogeny, which is really what we refer to as a mountain building phase. We kind of call those an orogeny. And so this is the result of these plates coming together, Farallon plate, the Juan de Fuca plate, coming together, pushing together, we believe. But again, not slow continental drift, but rapid movement. And so the accretionary phases of that taking place, adding material, crushing it together, sometimes pushing up, and then mountain ranges. And actually, if you follow the Cascade Range, there's a really nice ribbon kind of going right down them. There's many of these volcanoes. If you trace them out, they actually are in a perfect little alignment. And it makes sense because that's where these plates are coming together and subducting. So right around that same melt zone, right where the plate is melting and kind of up and down north to south zone, this is where you're seeing these volcanoes kind of pop up. And I found a neat picture actually earlier when I was looking for Cascade ones, and this is kind of an old vintage picture, but I love the look of it. Fantastic mountains that you can see there in the Cascade Range. So you're looking here, the first one kind of closest to you there, that's called Three Finger Jack. Behind it, you can see Mount Jefferson and then Mount Hood in the distance there. And so you can actually see a fourth one if you look closely way back there. And there's actually one even closer to the view to the left. But these mountains are basically all kind of lined up. And so this coastal geology range, you can see some spectacular volcanoes. And of course, and especially, following creation and stuff, I'm sure people are very familiar with one of the very famous volcanoes near that coastal range. And that, of course, is Mount St. Helens. And so, as we know, Mount St. Helens erupted May 18th of 1980. And this is actually not that event right here. This is actually after that. There was a smaller kind of little lava dome to begin to form inside of it. So if you actually go to Mount St. Helens, and I've been up there a couple different times, and if you look at it, you got the big, basin caldera in the middle, and you actually have like another little volcano. So it's actually, if you look at it today, you kind of consider it a little mini volcano within a much bigger volcano. Now, that mountain has erupted multiple times in the past. And of course, the last big eruption was May 18th of 1980 when it erupted, and that whole front side just kind of slumped down from an earthquake that kind of broke the rocks loose, and it kind of like when you shake up a bottle of soda and you remove the top, it just sprays out. And so kind of that's what happened. You have all this material when it was sliding off from that earthquake, the pressure inside that was being built up now just kind of exploded out. And it kind of came out unexpectedly to one direction. Instead of just kind of shooting straight up, it actually came out toward the direction of many people that were actually viewing it and watching it and recording, even scientists. So I'm sure there are plenty of talks out there that you've all heard on Mount St. Helens. But again, it's part of that coastal geology range, and pretty spectacular little feature that we have there. I say little, I shouldn't say little. It's actually big. And again, this is much bigger than what I ever expected. If you guys have never seen Mount St. Helens, really encourage you to go see it for yourselves. And I had seen many pictures, and boy, tell you what, this thing is so much bigger than what it looks like in pictures. It's like I tell people Grand Canyon, pictures don't do it justice. And the same thing is true for Mount St. Helens. Again, it's a spectacular place to see and to study, rapid geological processes and things that could happen pretty quickly, and even how the landscape could recover quickly. So along that whole region, we have some pretty spectacular geology. And a lot of that we can look at in relation to things like, the global flood, and maybe evidence of that flood, or evidence of what rapid big changes can happen from big events, you might say, catastrophic processes that produce pretty big events. So along that area, you actually have something a little bit to the south. So as we're kind of taking our journey along the coastal geology. We're kind of starting up here in the north. We're going to work our way north all the way down to the south where you guys live down there, Terry. So we'll kind of work our way from north to south, but kind of working our way down the coast. We've got the spectacular Cascade Range. We've got some volcanoes like you see here. We have another interesting feature that you can see if you go down near Portland area. And so I've got the opportunity to kind of drive through here and explore this landscape. And we have the spectacular Columbia River
Nate,
Gorge.
Nate,
Yes,
if you're showing something about Oregon, I'm still seeing Mount St. Helen.
it's still Mount St. Helens. Yep.
Oh, okay.
I haven't got to there yet.
Okay.
Yep. So we do have, this Columbia River Gorge, which goes down from there a little bit further south you could find. And a pretty spectacular thing. So it goes all the way to the Pacific Ocean. But if you go further back, you can actually see as it goes through many valleys and this whole landscape. Now, this whole region goes all the way to the Pacific, goes all the way to the coast, but it traces its way back quite a ways to the interior. So it goes quite a ways back. And in fact, geologists now, they believe that this whole valley, most of what you're seeing, the most, dramatic portions of what you're seeing here, were formed from a catastrophic spill of, a big lake system that was basically back there, all the way back into Montana, where we have this big Lake Missoula area. And so this whole thing was studied, especially going all the way back till about 1923. A guy by the name of J. Harlan Bretz, who had kind of surveyed this landscape, looked at it, and he was told by many people that these were valleys. And he looked at this whole landscape and said, this doesn't look like a typical standard valley. This actually looks like a channel, like a channelized region. In other words, to carve a channel, you need some kind of, typical water flow for the most part. And so he's looking at these massive channeled valleys, nowadays called the channeled scablands. And he looked at this and said, boy, this looks as if there was a tremendous amount of water that was spilling through here all the way to the Pacific Ocean, carving out these massive valleys and carving all kinds of things like big waterfalls, like dry falls that we see in the Grand Coulee region, which you kind of see here. And that Grand Coulee basically is showing where there was a massive big lake system, Lake Missoula, that they believe actually spilled through an ice dam, kind of burst through an ice dam. And all this water came together and began spilling through, topping over different areas. And as it went through where the Grand Coulee region is, it actually started to spill over kind of a cliff edge, where there was a waterfall, they would think. And this force and this amount of water actually had so much erosion happening during this big spill event. It caused that waterfall to continue eating backwards from that, that force of water from this kind of nick point erosion, creating this backwards retreating waterfall. And it actually retreated, they estimate, 20 miles. So going back 20 miles worth of cutting the cliff edge from this big spill of massive, lake system. But it goes all the way, and so many geologists believe that the Columbia River Gorge, the big features of it, most of that was actually carved by some of these big spills. And so as you go and travel through that region, you see and you can study some of this coastal geology all the way to the Pacific Ocean. And a beautiful landscape out there, by the way. If you guys haven't got a chance to drive up to Portland and check out the Columbia River Gorge and some of the areas up there, spectacular, beautiful views. There are some really beautiful waterfalls at Multnomah Falls. We got a chance to go up there. We went one time though in December, and I'll tell you what, the wind coming through that valley, that gorge, was so cold. It may have been some of the coldest I've ever been in my life. It's just something different about, when you're near the coast and it's cool temperatures and it's cool because of the water. Humidity kind of works both ways. Not only does it make, things feel hotter, but it makes things feel colder. And that's not me. I was raised, I like to say, high and dry. So I kind of grew up in the Southwest area and where it's higher elevation and very, very dry air. So I was up there and I was surprised at how cold it was, but beautiful landscape. Encourage you guys to get out there. Now, the neat thing about this whole study of the, Columbia River Gorge, Lake Missoula, Channel Scablands, this whole theory that that Harlan Bretz had kind of proposed, was he was coming at it for the first time kind of by himself, and he had so many detractors in standard geology that just kind of said there's no way any of this makes sense, and they were trying to laugh him out of the room. And he kept trying to push and push and push and try to share that this is a big flood event. And basically people were laughing him out of the room. Oh, the big flood. Yeah, what are you talking about? Like Noah's flood? And he wasn't even talking about Noah's flood necessarily. He was simply saying look at this landscape. If you study it, it shows that there was a big event that took place for this big feature. And of course, in those days, most geologists were only looking at slow, gradual processes, only looking at, slow uniformitarianism. So here he was trying to showcase something that was very different to what they were typically thinking and what they were looking at. And so if you go there to a Dry Creek Falls area where they have the little monument plaque, and it's kind of neat to see this. And this plaque, dedicated to J. Harlan Brett, says, "Who patiently taught us that catastrophic floods may sometimes play a role in nature's unfolding drama." And so I think that's neat, because again, it shows us that there are some pretty big events. And of course, the Bible describes a really big event. And those big events can cause a lot of change rapidly and catastrophically. And so again, when we think about not just a Lake Missoula sized event, but a global flood event, there's a lot of geology that you can really see and a lot of stuff that could take place very, very quickly. So as you continue driving down the coast from there, beautiful landscapes. Again, the California coastline is spectacular. It seems like if you're taking a road trip, you need to plan an extra day just to drive and stop and take pictures and enjoy yourself. And highly encourage you guys to do that. As you're looking at the California coast, what you see oftentimes, sometimes there are sandy beaches down below, but you see a lot of cliff areas. So we do have a lot of coastal cliff areas. And so we were talking earlier about kind of the coast of England, and there's a lot of cliffs there. And we're talking about Dover, and I've been out to Dover many times and seen the white cliffs of Dover, big sheer cliffs. Because oftentimes at cliff edges along coastal geology regions, what you see are that these waves are continually pounding these cliffs, and it's causing them to fall apart and to break apart. And so you see many places where you'll find cliff lines, and you'll see, the continual pounding of that surface just hitting in it. And water is a pretty good, powerful, erosive, mechanism. So it's continually hitting things. And I remember when I lived in Southern California, we actually had places down there near the southern, kind of the South Bay area, like San Pedro. And there was places where the houses that were right there on the cliff edge, houses had fallen into the ocean and passed, and the land had slumped away because building a house near the shore, it's not necessarily good when you're building it on, sinking sand, right? I think there's a song about that, isn't there? Maybe a verse, but yeah. So don't build your house on the sandy land, build it upon a rock, because if you build it too close to the shoreline, well, that's going to eventually tumble in. And so you can see in this picture here, big boulder, kind of big square rock in the middle of the water. Well, something that has either fallen in or has tumbled in or has been left behind as the rest of it was kind of cut back. Well, as the water's cutting through here, eventually even this big rock is going to dissolve away, get washed away and disappear. And so as you continue pounding the coastline, even the features you would see, that are once coastline you might be building on, well, even here, these coastal features are going to erode. They are going to get continually pounded. And it leaves behind, when they erode, it leaves behind typically these nice vertical cliffs. And that's what we see in many places around the world where there's erosion. You can see where they erode out, that they leave behind kind of these nice vertical cliffs. Big sections kind of slump off. They don't always tend to weather out into slow sloping beaches. If it's harder rock, or if it's rock that's bound together a little bit stronger, either through water, moisture, or things like calcite to kind of bind as gluing agent, what you're going to see is they're going to hold their shape, but when they do break off, or when they come off, they kind of cleave, almost like icebergs do in the ocean up in the Arctic and Antarctic. They kind of cleave and they break off these big flat sections and chunks. We see it at the Grand Canyon all the time, especially with limestone. It tends to cleave these nice vertical faces, and the whole big chunk slumps in, kind of like you see in this picture here. You kind of see that big chunk of rock in the background, the distance there. It's kind of broken away from the cliff edge. But over time, even that big chunk is going to also erode and disappear into the sea. And so you're going to have the ocean continually eroding and cutting back. So, when I lived in Southern California, we had all these really nice multi-million-dollar properties that you would see right on the coastal edges. And probably not the smartest place to build your multi-million-dollar house, because pretty soon it's going to end up in the ocean. And that had happened certainly out in that area. So what we see, though, as you're driving around, we see that there's continually erosion taking place. There's weathering, there's erosion, there's breaking down of the coast in many ways. And of course, as it breaks down, what happens? Well, a lot of that material forms what we call sand. And so if you start to look really closely at a lot of the sand, it's typically made up of all the different rocks and material that were once making up part of the mountains or the cliffs that were nearby. In fact, a lot of our sand there, especially on the Pacific coastline, a lot of that sand is mostly coming from granites. And so you take a look at it and you see quartz and feldspar and a silvery mica flakes in there. And a lot of the sand you would see, especially in Southern California, in that region, tends to come from the San Gabriel mountain range. So they've actually done some kind of figuring out of the fingerprinting of it coming from the San Gabriels. And some of that material kind of weathering from there, being washed down. But a lot of it also, we believe, was washed off those mountains as the flood itself was retreating off the continents. We have a lot of erosion that's taken place off the continent, and a lot of that took place, we believe, during the flood, near the end of the flood as waters are receding. But of course, it breaks things down and it continues to kind of pummel these rocks, rounding them down and making all kinds of beautiful rocks, making beautiful beach glass that's been rounded and frosted by the wave action and by the salts and things like that. So we end up seeing some beautiful coastal areas. Of course, one thing California is also known for, especially Southern California, the beautiful beaches, and everyone wants to go out there and the surfing and the beach and all that fun stuff because that sand, it's not too terrible if you take a spill and you got a bunch of sand underneath you. But if you're on your surfboard out there and it's all rocks and sharp, jagged stuff, not the best place to go surfing. Yeah, that's why Southern California is one of the capitals of surfing in the world. But of course, you have all this nice big sand. And a lot of the sand, again, comes from sandstone, comes from granites, comes from weathering and transportation material. And so we have a lot of sandstone you can see in the region. And so interestingly, when you start to look at sandstone, we have a pretty good layering of sandstone even around the planet. One of the things we point out at the Grand Canyon and all of our river trips are the sandstones that we see at the Grand Canyon. Some of those are really big in size. One of those you can see is what we call the Tapeats sandstone. And so if you look at this is a picture I took a couple of years back in the Grand Canyon, a little side canyon called Blacktail Canyon. This is a picture of what we call the Great Unconformity. This is where we believe the beginning of the flood is represented. The rocks underneath, the crystalline basement rocks are kind of going tilted or kind of vertical. Those are part of the pre-flood world, we believe. And then where it starts to go flat and horizontal, that's the Tapeats sandstone. And now the interesting thing about that Tapeats sandstone, if you trace it out across the United States, it basically blankets most of North America, like you see here. But every time I do a tour and I have anybody from the Pacific coast, especially California, Oregon, up there to Washington, or I get people from Florida down there, they start to look at this map and they say, well, wait a minute, I don't have the Tapeats sandstone where I live. What's going on? Well, how come it's only in the middle? Again, the flood, I believe, explains that nicely. This Tapeats sandstone you see here, blanketing across the United States, is not just found here. As you can see, it goes down into parts of Mexico. It goes further up. It actually hooks around into Canada, it goes further to the north quite a ways, hooks around, arcing all the way into Greenland. You could also trace the same Tapeats sandstone equivalent across all of North Africa, into parts of Europe and into Asia, through southern Israel, through southern Jordan, and all the way through there. So this is a basically cross-continental blanket of sandstone. But there are a few places where you don't see it. Some of those places would be maybe where there's glaciers that have kind of scraped away the surface of the landscape, where there's higher uplifted sections. But you're also missing it oftentimes around the coastal margins of these continents. So when you start to look at the coastal geology, you start to look at the coastal regions along the west coast there and to the east coast, you're saying, well, wait a minute, how come we don't have the sandstone going all the way across here? And again, I believe the flood explains that nicely. And it has to do with the retreat of the flood waters off the continents. As the flood waters are receding, they're dragging with them tremendous amounts of freshly laid sediment. And so as the waters are receding off the continents, more water is rushing off of the coastal areas. You're basically seeing more water rush off of there because all the water in the interior of the continent is continually going off the coastal areas into the ocean. So you have much more erosion taking place. The middle region, and really by and large where you see it, is kind of the mountainous region in some places, like the Rockies, a big section right there. This is uplifted. And so there's not as much water to rush off of there because most of it's already kind of drained away, but it's draining toward the coastal margins, the coastal fringes. So on those areas, you see what we call sheet erosion, where water acts as a big sheet and it starts to pull material off of these continents and erode them down. And you guys, especially that live there near Santee or Southern California, anywhere along the coastal regions, you can really see sheet erosion and this kind of coastal erosion all the time. You go and take a look at the ocean at the beach, and many times you'll see this nice sloping beveled edge that kind of goes right into the ocean. And what happens is if you watch a wave, as this wave rises up, it kind of pushes, it carries sand and seashells and debris. But as that wave retreats and recedes, this big sheet of water pulls back, it draws with it and it drains with it tremendous amounts of sand and seashells and debris. So it rises up and then it rises, or it draws back down, and it drags with it material off of there, and it pulls material down into the ocean. If you leave something sitting there too close to the edge, well, there's a good chance it's going to get pulled into the water. And that's what we would see, but on a much larger scale. Imagine not just a wave, but massive water covering the continents that it's now receding off the landscape. It's draining away, it's pulling material off of those continents. And as it drains away, it kind of draws that material down into the ocean basins. And so along the coastal areas, it's sloping downhill. More material has been scraped away, kind of beveled off. And so, around those coastal regions, you are missing some of that Tapete sandstone that was initially, we believe, deposited, initially would have been laid down there, and then subsequently scoured away at the end of the flood. So sorry about it, but if you want to come see the Tapetes, come hang out with me at Grand Canyon. It's a terrible place to come visit, but come enjoy it. Or if those of you who live in the Midwest, you can also see that same Tapete sandstone equivalent out there near the Wisconsin Dells. If you go up to Baraboo area to Devil's Lake State Park, you can actually see the same great unconformity, the exact same Tapete sandstone equivalent, and it's spectacular. I've gone up there too as well. And so you can see that rock layer extends across many places. You find it again through the Middle East. In fact, most of you guys have seen it also. If you've never been to the Grand Canyon, even you've seen it if you've ever seen like Star Wars, some of those movies where they're flying in through these like canyon valleys and stuff. That's typically through places like Jordan or through places like Northern Africa, where you have the same kind of Tapete sandstone equivalent over there. But anyhow, you are missing it with coastal geology by and large. And so what we see is on the coastal regions, you have a lot of erosion taking place. And again, especially near the end of the flood. But you do have some spectacular other geology left behind. And so not just, sand and some, igneous sedimentary rocks, you also have igneous rocks. There are volcanic rocks nearby. When I lived in Southern California, one of my favorite things to do would be to go out and do some rock climbing. So a fun little picture up in the top left, I used to take my students out there and train them how to do rock climbing. And there's a really neat place down there called Pelican Cove. And if you look at the bottom left, somebody had actually put some anchors, some actually rock climbing anchors into basalt. And so if you know anything about the California coast, there's not a lot of good rocks to climb around there because it's all kind of loose and crumbly and mudstones and siltstones and just really breaks apart, really friable material. So it just kind of falls apart. But there's a few places where you have some jutting of basalt material. And so this is one of the locations that we used to go out and climb, and I take my students out there. And in fact, the middle picture you see, it's kind of neat because it's not quite seen as much in this picture, it's more near the top, but it's actually some beautiful kind of columnar basalt, columnar jointed basalt, similar to what you would also see in California at Devil's Post Pile, or over at Devil's Tower in Wyoming, or over there in northwestern Ireland, where you see Giant's Causeway. You see this kind of columnar basalt, columnar jointing. And that is typically formed, we believe, where there's basalt that comes in contact with a rapid cooling surface, mostly from water. So it oftentimes is seen where basalt contacts water. We actually have a lot of it in the Grand Canyon itself from lava flows that have flowed over the rim of the Grand Canyon after it was carved, spilled all the way down to the river. And there are miles and miles and miles of columnar basalt down there. Pretty neat, spectacular stuff. But anyhow, you have beautiful coastal geology regions, not just having to do with sedimentary rocks, not just sand, but also some very unique, interesting, fingers of basalt that kind of stick into the water sometimes, a strong, hard rock. So when I lived there, it's great to climb around to play in that and to take your students through there. And nearby, also down there, just kind of near San Pedro area and kind of the LA South Bay Harbor area, Some other very unique things in geology, not necessarily just basalt hard rocks, but we also have sedimentary rocks. And here's a great example near that area of sedimentary rock that has actually been folded and bent up. And so I've seen that down there too, where you can definitely see there are tectonic forces and things taking place. This whole sequence of rock has been bent up and out of shape without really indications of metamorphic change to it. So this is a kind of a good indication, I believe, that this sequence of rock was deposited before it had a chance to fully firm up and become hard, before it fully lithified. It was actually pushed and bent up. And you can see it kind of bends and folds back on itself. And so this is a great example. And you may be familiar with Dr. Andrew Snelling's research with us here at Canyon Ministries and at the Grand Canyon on the bent folded rock layers. And brand new film called Is Genesis History? Part 2 called Mountains After the Flood really features that research project and that landscape. And so whenever you're seeing, bent folded sedimentary rock, I would say take a look and see, does this exhibit signs of metamorphic change and process? Or does this appear to have been bent and folded while it was still soft? And there are places throughout, especially Southern California, that I've seen where you can see these kind of processes and things taking place. So again, this we believe would have been formed probably right after the flood, when there's still some changes, uplift and movement. We have really good evidence that even some of the California coastline in some areas, some of these cliffs have actually been pushed up out of the waters even after the flood had left. But when you look at the landscape and you start to look through all the way down here through Southern California, there's another neat feature that you can see. And if you kind of look, starting all the way back here where I live in Arizona, we've got this little thing called the Grand Canyon. And you can see that Colorado River flowing down through there. Well, that Colorado River, as it comes through here, basically starts to make the border between a little bit of Nevada, but especially California. Once that Colorado River goes into Lake Mead, it basically turns straight south. It goes straight south from there into the Sea of Cortez down there by Baja, California, going straight south. Now, when we're looking at the Grand Canyon, many people ask, what happened to all that dirt? Where did all that material go? We have roughly 900 to 1,000 cubic miles of sediment that have been removed from the Grand Canyon. Where did all that dirt go? Well, here's an interesting thing. If the Colorado River carved the Grand Canyon, it should carry that material all the way down through the Colorado River as a giant conveyor belt and should be found piled up at the very bottom down near here where the river enters into the sea. And but that's not typically where we're finding material, not way down here where the river goes, way far south. Where we actually find this material by and large is actually blanketing parts of the Mojave Desert and parts of the Anza Borrego Desert down here near Southern California, even to coastal areas. And in fact, there are geologists that believe that the LA Basin actually sits on top of Grand Canyon sediments. So you might even say the coastal geology of Southern California is actually directly related to the Grand Canyon and some of the stuff that we see here. Some of that material that we are seeing in the Grand Canyon has been dumped out there. And in fact, a lot of it probably dumped out into the ocean when the Grand Canyon was carved itself. And so part of coastal geology is not just about what you find locally formed there, but what has been brought into that region. We have big river sections you can see up here between Sacramento and the San Joaquin Valley there, where there are massive rivers that are pulling material out of there. And a lot of the material from these mountain ranges are being carried further downstream and dumped out there. And it's a great way to study geology that maybe comes from a different location. So for example, if you go out there to the Mojave Desert, and if you were to drive out there to the Mojave, I encourage you guys sometime, if you're in the Mojave or the Anza Borrego, pull over, take a look, get out of your car and go start to look at the rocks and the gravel. And you'll see as there's a whole collection of material out there. And all this material basically are made up of all sorts of different types of rocks. There are sandstones and limestones and shales. And I've gone out there through Mojave and looked at this and said, this is Kaibab limestone, just like we see at the Grand Canyon. This material is blanketing the landscape, going all the way out there to the Anza Borrego Desert area like you see here. And so the interesting thing, again, if the river carved it, it should be found at the bottom, but it's not. It's found way over here, kind of into Mojave Desert towards San Diego, Los Angeles area. And so again, even part of coastal geology has to do with what we see over here where I live. And so it's neat, fascinating to study that. Now, that's kind of a snapshot of a few features that we'd see from coastal geology in the region. And a few interesting things that I tend to like. Again, we could focus on just one of these topics and do a whole hour on just one of these things alone. But talking about studying and research, one thing that I would love somebody to do in the creation community is really study some of these big canyon valleys that you might see off the coastline areas. You can see some sections here where there's actually some massive canyon formations underwater. And so some of this we believe was because at the end of the ice age, during the ice age, we had a lot of glaciers on the land. The ocean levels were dropped down. We know that there are actually, entire communities and villages that are now underwater where they used to be kind of flat coastal regions are now inundated by the water. But imagine, as the glaciers are melting, there could be some other big catastrophic events, not just like the Missoula Lake bursting, but other big events, not just creating canyons we see on the continent, but even canyons cutting down into these coastal margins. And, naturally, it's kind of difficult to study underwater geology, but I would love to have somebody in the creation community start to study underwater geology and start to put together, because if you were to even jump on Google Earth and look at the landscape, there are tremendous canyons and valleys and gorges and stuff that really looks like it was carved while water was moving across dry land. And then maybe some of this also where there's water, draining off from rivers and big, storms and stuff off the continents, and maybe some of that colder, denser water sinking down and causing, underwater erosion at the same time. But it's a fascinating thing. So it's one thing that I would love to do, get somebody out there that can do some deep water diving and survey some of the geology that's off there. Who knows what we're missing because we're only seeing what's on the continent. But anyhow, I know we've been talking quite a bit about some of the coastal geology. And again, there's so much to see. Again, driving up or down the coast, you can see all this stuff and just beautiful landscape where you guys live. And I want to leave some time for a Q&A here in a second. But as you're driving along the coast and as you're looking at all of this beauty, I want you really to remember this, like all of this entire world, this proclaims the glory of God. And we as Christians, as those who believe in God's creation, have the ability to study this and to help see God's glory revealed. And so I'll leave you guys with a very fantastic verse that I really love to share on all of our tours. Psalm 111 verse 2 says, "Great are the works of the Lord, studied by all who delight in them." And so this is something you guys that live along the coast can absolutely do. You have a beautiful coastline you can drive from top to bottom and see the coastal geology that God has given, and encourage you guys not just to see that beauty, but to study it, because God's works are great. They're spectacular and beautiful. And I love it. Great are the works of the Lord, studied by all who delight in them. And so as we're driving, as you're exploring, as you're seeing this landscape that God has made, remind yourselves, take delight in his works, because God, as a good heavenly Father, has given us, his children, good gifts to enjoy. And again, that coastal geology, fantastic place to enjoy that creation. So with that, I will kind of wrap that up and turn it back over to you, Terry. And if there are people that have questions, we can certainly see what we can do, or comments that they might have. And I'll also open up the chat. In fact, I'll close out my screen here, so I'm not sharing.
Perfect.
They can see you now, hopefully.
Yeah, that was so great. Very informative. And we like visuals and we like colors, so it was very engaging and interesting. And we do have some questions. So I want to comment first just how blessed I feel, because God has, in my personal life, in the last couple of years, we've had some big changes in our family and very sad things, but I've also been afforded the opportunity to drive this coast several times. And I'm just saying, like, I had done it once back in 2014 with my son, and before I took my first trip on the drive along the coast in the last couple of years, a couple of people told me, just wait till you see the Oregon coast. And I didn't remember the contrast between the California and the Oregon coast. Like, California coast, there's some really beautiful scenes, but once you hit that border and you get to Oregon, it's just amazing.
I agree.
Why is
Breathtaking.
I mean, why are they so okay? I know there's other questions. I'm just jumping ahead here.
Go ahead, Robin.
I did notice a big difference between the California coast and the Oregon coast. And then we didn't hit much in the Washington coast. We did a little bit. But there's a big noticeable difference. Is it because of the weather? Is it because what is?
Mainly it has to do with the geological processes of, that Farallon plate, the Juan de Fuca plate pushing against the North American plate. In some cases, it's subducted more easily, and so it hasn't created such a collision, you might say. It hasn't pushed up as much stuff, but in some areas, you actually see more push up, more volcanic activity, and that's what you see, especially up there in the Cascades, along Oregon, Washington. You're seeing a lot more volcanic activity. I mean, all those volcanoes are up there, kind of that Pacific Ring of Fire. So you tend to see more mountainous regions, more hard rock coastal areas as well, because of just what's happening between the contact of these plates as they're coming together.
And then you had a slide up that looked like the Oregon coast. There was a bridge going, and then you made the rock disappear. Do you know where that picture was taken?
The one with the bridge.
Yeah, and then your graphics makes the rock disappear, and then it
Yeah,
makes.
those were two different pictures, but the one at the bridge, I can't. Somebody might recall because it's a pretty famous picture I've seen before. I don't recall where it is. I got it off of a stock footage site.
Oh, okay.
So
I thought maybe
I
you.
can probably find it for you. I can probably
No,
figure it
no,
out.
that's all right. I thought you took it. We
No,
had
I did not
stopped
take
at
that one.
a lighthouse in Oregon, and that area just looked so much like that area. But Terry commented to me that they probably all look alike. But
Yeah, I
it,
mean it's somewhere along Pacific Coast Highway, as you're driving up through there. So
thank you.
yeah, I've seen the picture before, but I can't recall the name of that exact location, but I can probably find it for you.
Well, and can you repeat? I think that you said something about that Mount St. Helens. There's a volcano within a volcano.
Yeah, so the main eruption, the major big eruption, we're talking about 1980, but then after that, especially around like 1983, we started to have more kind of pluming up, and it was kind of a lava dome. So the big eruption happened here, but in the middle of it, this kind of lava dome started rising up, and so you can see in that picture that I showed some steam, water vapor coming out of there. So it actually kind of created like a little mini dome, like a little volcano dome within the much bigger volcano, caldera. So if you look at it, it looks kind of like a little mini volcano inside a much bigger volcano, which is really these volcanoes have erupted multiple times. So you actually have layer upon layer, typically kind of a stratovolcano, multiple layer events that have kind of formed this big sequence of volcanic eruptions.
Okay. And then we have Bill Morgan, one of our past speakers, with us again. And he's asking, is that underwater active volcanic activity evidence the Earth is young, or at least the formation of the mountains under the ocean being recent?
Yeah, and I've heard this multiple ways. I would say kind of depends on where somebody might be talking about. We have volcanic eruptions in the middle of oceanic plates from hot spots where magma's pluming up from there. I personally don't necessarily see a lot of like evidence supporting a young Earth perspective from that, simply because even in older perspective geology, you could have hot spots rising up from convection currents underneath these plates. And so we have these convection kind of currents that are moving that could actually create a warming hotspot zone in the middle of a plate. But I would say somewhat related to that is the fact that we do find some plate material that is still subducting into the hot, asthenosphere or down into the mantle that we should not expect to find if the Earth were millions of years old. For example, some of these plates that have subducted should have had adequate time to already melt, to already have the process of melt and then rising up. But we're still seeing some cold plate material down into these zones where it's hotter, and they should have had enough time for millions and millions of years to kind of equal temperature. And so some regions you might have that, but I'm trying to think of any like underwater volcanoes that would be evidence of a young Earth. I'm not exactly sure. And Bill, I know you know a lot about this area. You might even have a great answer to that, or a great thought that you would even have. And so if you're here, I'd love to hear any thought you have on it too.
So you could go ahead
There
and
we go.
unmute. Yeah,
Yeah,
go
hey,
ahead.
Bill.
Sorry about that. I was thinking like the Mid-Atlantic Ridge
Oh,
had so
yes.
many active hotspots that if it was happened billions of years ago, it would have petered out by now. But I'm no geologist.
Yeah, and I'm thinking all Pacific area because I'm thinking coastal geology in the Pacific. Yeah, Mid-Atlantic Ridge. Yeah, that's still, I mean, you've got movement over there. And I think, again, that's where we're seeing push apart, where continents are moving apart in different directions. Again, today's processes are much slower. And so some of the activity that we would see through there could perhaps be that. Or the geologist could simply just say that the convection currents are moving these continents still apart. And as they're splitting apart, it's exposing heat and magma that's coming up to kind of fill in the void. So anyhow, but yeah, I mean, there's definitely still a lot of activity that is making things very, very active that you would think over millions of years, some of these regions would have either slowed down quite a bit more or come to a complete halt and seized and frozen up.
Thank you and great job.
Thanks, Bill.
And we have another past speaker, Thomas Lohman, who's watching along with us on Facebook. And when you were talking about the volcano within a volcano, he said like Crater Lake in Oregon.
Yeah, just like that. Yeah. In fact, we see that many places. We're northern Arizona where we live. We have 600, 650 volcanoes here. And we have a lot of these cinder cone volcanoes. And many times inside of a cinder cone, you have this like big mound, you have the big open, caldera kind of cinder cone open spot in the middle. And in the middle of that, you also have like a little mound again, because typically, even though it erupts, you still have a smaller push up in the middle. So I would say oftentimes where you find volcanic, openings like that, you do find some kind of like little push up. And it may not be an explosive volcano, but it's a place sometimes where just more magma has kind of oozed up or mounted up. And so, yeah, a lot like Crater Lake, you got this cool little feature right in the middle there, huh?
Okay. And then back here in Zoom, Dan White is asking, is there evidence of silt from the Columbia Gorge area out on the shelf into the Pacific?
Yes, absolutely. They have done some underwater dredging and some samples and stuff like that. And so they know for a fact that the material off the coastal sections there comes from that Columbia River Gorge. In fact, it still does today. Just from the river itself that's flowing through there, it's continually removing material from that whole region and then carrying it out into the Pacific. So even today, we have fresh continual material being pulled off the continents and dumped into the Pacific coast shelf areas.
Okay, next question. Robin would like to know, is basalt the same thing as pumice?
No, not necessarily. Pumice tends to become much more light. For example, it's like the opposite end on the igneous volcanic spectrum. They're both igneous rocks, both volcanic rocks, but pumice tends to happen where oftentimes there's contact with water, which creates a lot of steam and bubbles and things like that. So you end up having a whole lot of trapped gas and bubbles within the volcanic material, making it very, very light. I do have some pumice around here somewhere that I collected recently, but it makes it very, very light. Basalt's almost the exact opposite. Basalt has a lot of iron, it has a lot of magnesium within it, making it very, very dense. And so it's very strong, it's very hard. And so, they're both igneous rocks, both coming from volcanic events sometimes or from magma oozing up, but kind of the opposite ends of the spectrum when it comes to chemical composition, as well as, just the weight and material. Pumice tends to be very, very light in color too. So a lot of your pumice is whitish, kind of gray in color. You have other rocks kind of in between, like we have a lot of these black and red cinders around here, which are a little bit heavier. They contain more iron to them, but then you get to the more solid black rocks of basalt. And so that's usually black to, very gray, sometimes even greenish looking sometimes. But yeah, great question.
Okay, and then also, I think that maybe you had touched on this, but she wanted to clarify, are there no creationists working on the canyons under the ocean?
I don't know that there are. There could be. I have not yet met everybody on this planet, so I can't say that there aren't, but I don't know. There could be somebody out there. I have not met them, and boy, that would be fascinating. I know when I've gone to many of these creation talks and seminars and big gatherings like this year, we had the International Conference on Creationism out there in Ohio. Went out there, and none of the talks that I saw were given about this topic, and I've not come across read anything, but who knows, maybe there is somebody that's starting to get into that, and that would be fantastic. I would love to see that.
Yeah, that would be great. And And then just another comment from Dan, going back to when we were talking about the difference between the California and Oregon coast. He said another reason for the coastal differences in relation to what you were talking about, they're covered with the massive erosion from the Grand Canyon area down to the California coast, as opposed to not much massive erosion releases in the Oregon and Washington area. So
that makes sense. Yeah, I mean, a
Yeah.
lot of material, the sedimentary material we see here was carried and dumped out across there. It's a low-lying region, so naturally, even from not just Grand Canyon, but from the whole area, you would have a lot more of that broken up, turned up sedimentary material that kind of blankets that area. Yeah, that's a great observation, Dana. I like that.
okay, well, we've reached the end of our questions. We've also reached the end of our time, because we'd like to have a little bit of time left for some fellowship back here in the Zoom room. So if you, Nate, can tell everybody one more time how they can find you, how they can support your ministry, we'd love to be able to let you have that opportunity. Go ahead.
Absolutely. Thank you, Terry. Yeah. So Canyon Ministries, we have been running trips and tours from a biblical creation perspective at the Grand Canyon for 26 years now. And so we run river trips, we do backpacking trips, we do hiking tours, we do walking tours, we do vehicle tours every day except for Sunday. Year round, we have those kind of tours happening. So canyonministries.org, people can find out about that, sign up for our trips and tours, or just simply Google Grand Canyon Christian Tour or something like that. If you can't remember the name, you'll find us out there. And we serve between 3,000 and 4,000 people a year at the Grand Canyon and throughout the American Southwest. So I'd love to see any of you guys out here. Love to be able to be that guide that day for you. We have a whole team of guides, so I might be it, but we have a whole team of guides. And if you want me, well, just put my name on the request when you see that, when you make that reservation, and I'll try to jump on there. But it's always great to see all of our creation friends or anybody that we meet on these sessions come out and see us at the Grand Canyon, and it's a neat place to be. And in my opinion, Terry, it's the best place in the world to see and to study and understand flood geology. It's no place quite like it on the earth.
Yeah, I'll amen to that. And just getting out of the car at the first point when you get there and stepping out and just seeing it, it's just breathtaking. I'm just gonna say, if you haven't been to the Grand Canyon, you need to go. So, and once again, we are Creation Fellowship Santee, and you can find links to most of our past presentations, and you can also find a list of our upcoming speakers by visiting tinyurl.com/CF Santee. That's C like creation, F like fellowship, Santee is spelled SANTEE. Next week, we have Ryan Cox will be coming from Creation Truth Foundation, and he'll be giving us a great message on the heritage of Thanksgiving in America. So you'll want to be looking forward to that. And with that, we're going to go ahead and sign off for this evening.